Good morning. Thanks. This talk is not about Elasticsearch. I'm sorry for that. So, my name is Friso. I'm on Twitter and I have email. I work for a company called Go Data Driven. We provide services for people that want to do interesting things with their data. That means that apart from building solutions, we have to do a lot of kind of grunt work, like the mundane things that need to happen when you do things with data. And that's basically what this talk is about. It's about the mess you get when you use other people's data to do something interesting. So I'd like to start out by giving you basically some examples of what we're talking about. So this is a simple plot of a number of unique visitors per day of the week. You can see Monday till Sunday on the horizontal axis. And well, weekdays are busier than weekends. This, by the way, is in millions. So you see, we average at about 4 million uniques a day. And Friday of all the weekdays is not exactly the busiest day, but there's these two interesting things there in the top. You can see them, right? So those were really good Fridays. So you start looking into that. And then it turns out, well, Fridays in February are great. For some reason, it's the bar over here. So you start thinking, what happened there? Because what's so special about Fridays in February? This is just the Fridays. And you can see there's even a downward trend for this particular site. But still, there's February. So you start wondering about these things, and you wonder, is this a data issue, or were they actually exceptionally good days? And then when you look beyond that, you can see that February is actually doing quite okay altogether. And then you have to look outside and see that in that month some particular interesting events were happening in the European Football League, and that it actually makes sense that it's there. But very often it's the other way around. You get twice the amount of data that you should be getting, just because, and you have no idea where it comes from. Or you get 15% more than you should be getting. And that's, if you know upfront some kind of hard count on what you should be expecting, that's even not so much an issue, because you can just build in a simple check. But what do you do if the right number of records that you should be receiving in a day is somewhere between 20 and 50 million? Depending on the weather and whether there were sports events and those kind of things that influence a news website, for example. So that's one example. So you can have too much or too little, and it'll come in. Does anybody know this particular XKCD comic? Yeah. So you would hope that this by now would be kind of general knowledge, right? We have an ISO standard, and then I'm not even complaining about the lack of time zone information, right? Because we know everybody keeps their servers in Zulu time, right? So a lot of people think this is perfectly fine for a date format. And you get this a lot. And the kinds of things that we ingest is not only large sets, but there's also people that just deliver us like small pieces of stem data. And it comes from Excel files somewhere, and it comes from I don't know what, somewhere else. And you get this stuff, a lot of it. So also there you have to do something. And then the other day, the guy that does the Excel trick to make these things is on holiday, and somebody else takes over, right? And they have their Excel in a different locale. So those things will break at some point. A lot of people push data through S3. Do you think it ever fails? Well, of course it does. But also a lot of people push a lot of really small files to S3. And the funny thing is, the web service call for getting a file will actually fail about 1 in every 10,000 times at some point. So if you take about 3,000 files per day, then two times a week, your import will fail. So that's something that you don't really want to nurture yourself, right? You don't want to be pressing the button every time that happens, because it will happen anyway, and you have to be somehow prepared for that. Oh, this is another one. This is funny. What is the difference between a 0-byte gzip file and a 20-byte gzip file? It's the header. So the 0-byte one obviously breaks the codec, right? And the 20-byte one is actually the empty file. But there's a lot of people that generate 0-byte gzip files. Who knows what this character is? Ralph does. So this is the Thorn character, or the Icelandic Thorn character. It is encoded as a 254 unsigned byte in some encodings, most notably Latin 1 in the Windows encoding, which is exchangeably what Windows uses. And at some point, somebody sends you a TSV file, right? So you think that's a TSV file. It is, kind of. So okay, it's a separator, right? And people choose to use 254 for that, and that's kind of okay still, although we would like to have our separators somewhere, nearer to 0, because low-value separator characters are nicer for sorting order and those kind of things. But anyway, it's a separator. You can split on it. It'll probably work. Yeah. Do you know that it's a signed byte in Hive that you need to use for that? So these are some interesting examples of the kind of stuff that you need to ingest if you work with these external parties that deliver you data, and you have to somehow work with this. Right? And this is, of course, not an entirely new problem. A lot of people have this problem, and everybody's trying to solve that in their own particular way. And if you're in a large organization, you even have this kind of problems internally, so with your own data. And because for many people this is an internal problem, and especially for corporate organizations, this is an internal problem. So what do? They create a business out of it. They invent mechanisms for it, and they invent activities that you should be applying, and then everything becomes right. And, well, some call it differently. And then actually there's a role that you can have. You can be a data custodian. Is anybody that? Or maybe a data steward? Yeah. So what the idea is here is that if you apply all these principles and you follow all the rules, then your data is going to be in great shape throughout the whole pipeline, and everything's going to be nice, and all your use cases will work, right? But the issue that I at least have with that is that the people that do all this, they don't actually know about the use case. And so what they're going to do is they go upstream and say, you need to deliver the data in this format, and this shape, and this quality, because otherwise I'm not going to accept it. And then all the way down the line, there may be a data analyst who says, yeah, but I just want to get a rough estimate of this, and I don't care if half of it is wrong. I want to know whether the phenomenon exists, or whether this happens ever at all, or something like that. So by making it basically an organizational problem, you kind of lock yourself out of a lot of things that you could potentially be doing if you just get everything there is. But then again, if you get everything there is, then it does become your problem to solve it. And in the end, it turns out that it's not really that hard. So if you show this chart, this simple plot, to a data analyst, somebody who works with the actual data every day, they do their Hive queries and they do their R magic and then whatnot, and you just show them this plot for the import over time, then they will immediately spot those two, and they will immediately be able to say, okay, this is wrong, or this is wrong for me right now. So in essence, this is all the bad things that will happen. The format will change. We've had a lot of sources that were CSV-like, and they would just add 2 columns at some point in time. And of course, they would add them in the middle. So you have to be careful with these things. But then again, if you're going to accept all data from anybody and you make it your problem, then you will have to be able, above all, to respond really quickly to those kinds of changes. right? So the import breaks, I change some code, I deploy it, I run it again, and I have new data, and it works this time. So doing these kinds of plots for the actual analysts, for the business users, combined with a number of tricks that we use in order to do ETL and scheduling, those kind of things, basically got us quite well on our way there. So what I'm going to present is not so much something that we did on like a single project, but it's moreover a general way that we attack this problem, and for some customers we have slight deviations from it, but in the general sense this is kind of how we attack it. There's no rocket science in here. This is not a very sexy subject. It's making sure that your data gets into your store where you want to use it. But at least we did it in what we think is a developer-friendly way, and we use open source tools all the way. So what we want is we want to be able to have simple deployments of ETL code, meaning that the import breaks, I fix it, takes me 10 minutes, I deploy it, should be running immediately, without hassle. Okay, scheduling obviously is important. I need it to be scalable. I'm going to have a lot of jobs where we're talking 10, 15, 20 different sources from different outside parties. I want those to be as independent as possible, because dependencies between jobs is nice if everything just happens. You fire off the one and all the others will just work. But then the first one breaks and you have nothing at all. But maybe all the other ones can do their job partially. So if that's all independent, and if some of these things can do their job partially or break halfway or something, then we could end up in some kind of corrupt or inconsistent state in the data store itself, the thing that the analysts use. So I need that to be fixable in hindsight. So instead of upfront creating a whole process that is going to make sure that everything just works, I'm going to make sure that afterwards, if we notice that something went wrong, and I'm going to make very sure that people will notice, then I should be able to basically fix the problem in hindsight, redo the thing. Incremental where possible. Some people send us Excel files, but other people send us 10, 20 gigabytes a day. If it breaks halfway because of one S3 error, I don't want to re-download the other 5 gigs. I just want to have it there. Amazon being as fast as they are anyways. And metrics is important. You need to have these things, because otherwise nobody will notice when stuff is wrong. So what we're essentially talking about is ETL. It's getting data, changing it into something that's usable for us, like the funky date formats into something that's a real date format. And then you load it into whatever data store you use. We use Hive. And from there on, business people can use it. Okay. So who's familiar with ETL tools? Like these ones. So what these things do is they give you this 4GL environment where you can kind of connect the different steps in a process, and you basically just connect the dots, and then it will compile down to something that runs in some runtime, and it will execute the thing, right? It makes a lot of sense when you think about it, because it's nice. You get a view of whatever your ETL workflow should be doing. It should be able to do notifications when something breaks, and it'll be able, ideally, to handle whatever you come across by putting these little magic squares in your flow and say, change this to that, or something. Change the funny date format to a real one. So it turns out that at some point these things get a bit hairy and difficult to work with, and because what happens is you're limited in what you can do with these things, right? Many have some kind of script interface that will allow you to maybe do JavaScript against whatever data runs through, or some other scripting language that they have embedded. But then you need to somehow connect all the things. That first it extracts the date format from the file name, because that happens a lot, that the files don't actually have any date information, but it's in the file name. And even before that, you need to check on HDFS what is already there, and then on S3 what is already there, and you do the diff, and you only download the ones that are new. And then at some point, there's a provider that you kindly ask about what are the .staging.gz files in there, because we've been importing those. And they say, oh, no, you shouldn't do that. That's our testing data. and well, then you have to obviously modify this thing to do the inverse grep for the .staging somewhere. So this becomes a mess, but luckily they're a savior, because all of these tools at some point have this little magic square. Right? And then we're back. Then we can do anything, because this thing turns out to be this thing. And this is it, right? This is 50 lines, well, 41 lines of bash. Now, the problem there was that, well, we have the shell square. We write the script. The script goes into the tool somewhere. And then, well, you have a version, and you push it to whatever machine is actually running those things. And somebody else will need to, at some point, make an alteration. And you need to, well, version control would be nice. That's basically the issue there. And many of these tools have version control-ish. But not the real kind. So there's some work to be done, and also maybe bash is not the nicest thing here, because as powerful as bash is, it turns out not to give you the most readable type of code, especially when you do these kind of things, right? And grep and awk, I know, are the best tools ever, but maybe in code, in some other code, it looks nicer. But on the upside, 41 lines of bash is way better than this already. So we're improving here. So this is our bash attempt, and there's one more problem here. So what I'm going to do here for each file is actually put it to Hadoop. And many of these files will be small, and then there's the Hadoop move, and sometimes I need to create a directory. So these are 3 Hadoop command line usages, and that's fine if you do 3 of them. But if you do 3 of them times 3,000, or maybe 3,600 or something, it'll be 1 or 3 JVM startup overheads per file that you process. So your import just got 1 hour longer, just because of firing up a JVM. So this is the new version of the same thing. Anyone guess the language? It's almost Python. So what do we do here is typically the same thing. But you can see we have created some library code here. Like I want to have a HDFS file list, or I want to have an FTP file list, and it will just grab me the thing I need. And if I need to do other things, I can expand the library, but the core of the ETL will still be something like this, like a very concise script. And if you look closely, then we instantiate some classes here, and we talk to some kind of HDFS API, like HFS path, and then a constructor parameter, and some other things. So what is this? This is actually Jython. Jython is nice for this because it talks to Java, so it talks to Hadoop natively. You don't have the JVM startup overhead. It has Python syntax, so you don't have to implement the filter interface with an anonymous implementation to filter a list of files. But you can just use, well, almost nice Python. The Jython is up to the 2.5 spec of Python, so you don't get list comprehensions and dictionary comprehensions, but you at least have lambdas and some functional constructs there. So we went for Jython. We can use the Python standard library and also any Java library that we can find for our purposes. Hadoop obviously being one of them, but also there's a couple of nice FTP libraries in Java and some other things that you may want to do there. Performance is fit for what we are doing, right? The actual heavy lifting is just moving bytes around, and that happens even in Java and the Hadoop API, and the rest of it is, well, we compare lists of file names of a couple of thousands. So there's nothing too exciting there. So this is nice. Now let's do it every day, or every hour, or every whatsoever. So obviously, once you're working with code, the first instinct is to just cron it, right? Code goes in version control. I check it out in some kind of directory. I cron it, and it will run every now and then. So who's ever had the pleasure of managing a really big cron tab? So, yeah. So that's that wasn't too pretty, especially if you want to also at some point, kind of trigger these things manually every now and then because it fails or whatever happens, and you get these descriptive cron emails. They're also not the greatest to read. So enter Jenkins. Next piece of the puzzle. Jenkins is a build server, right? It's a continuous integration thing. But it turns out it's a really great scheduler as well. Also, the very nice property is that it saves all of your output. Whatever comes out of the job, you can get that to 30 days back, or however long you want to be using this. It will give you sensible emails on error, and it will actually give that really long output of your job as an attachment to the email, which is really nice. So you can open it in something, well, that's more appropriate for watching stack traces than your email client. Jenkins can scale to multiple nodes. You can have worker nodes in Jenkins. So if your ETL becomes heavy, you can add Jenkins workers and make the work happen over there. This is very nice. It will give you a status monitor, and it integrates with version control, obviously. So we can put up this wall, and we did, and then everybody who would work with data can, just when they enter the office, already see if something may possibly be wrong with their particular data. So that's very nice. They come in, they see that, and if they see a red thing, they come to your desk and say, "Hey, what happened?" And you can warn them about, well, this and this happened. What are you going to do? If it's that, you're fine. If you want everything to be up to date to the last hour, it's not there. I'm sorry. Because this is what happens, right? The data feed is supposed to be delivered at 11 to S3, and then sometimes it's not there, or sometimes when you check at 11, it's still, getting there. And then, well, what do? I mean, you can wait, but for how long? But also you can just start working and grab the rest of it the next day. So how do you deploy? That's easy, because Jenkins will just pick it up. And this is by far the most interesting thing, right? Something changes in the outside world, you have to respond to it. And instead of starting to click like an idiot in one of those things that has 1,500 squares with arrows going everywhere, I change a couple of lines of code maybe, and I do a git push, and then it's there again. Jenkins will run tests, and if it works, it'll pass through. So one of the other points that we talked about is having these jobs independent. And once more, there's no real magic here. It's just we want to make sure that if I do one thing and I do the other thing, that it doesn't matter necessarily if they just so happen to go out of order. And maybe I schedule one thing every hour because I like to have the incremental downloads, but I want to do the processing maybe twice a day for some data source because nobody's interested in the individual hours, and those kind of constraints. And if you create trees of dependent things, and then they always have to happen in that order and with those dependencies in mind. So what we try to do is make everything independent of each other, and that whenever you run a job, it'll do work if there is any, and it will just quietly quit without error if there is none. So By far the easiest thing to do here, and which we obviously did, and this is not a new trick, we put stuff in HDFS and we use move to make it go from staging folders to another staging place to eventually where the raw source data ends up. Moves are atomic, or atomic enough in HDFS, meaning that if you do a file listing in a directory, that everything you see will be there. So that means that if we upload files to HDFS with a like a .upload extension, and then when the upload is completely done, we move it into place to a real extension, and so everything that watches that space in HDFS needs to ignore the things that are mid-flight, that are in progress of uploading. Then there's transformation jobs, right? Many of them are raw map reduce because we do non-trivial parsing against some of these formats. What happens there is you basically do the same trick again. You grab everything that's in the staging area, move it out of there to some other place, do the processing. The result of that, you move into another place. And the other place is typically where we make things go into Hive. So we don't write Hive tables directly from the transformation jobs, but we write whatever comes out of it, usually even just text-based separated formats. And then we actually use Hive to map that as an external table and insert it into a real Hive table, where the real Hive table is something that has like RC file or some other columnar storage engine that works nice for analytics workloads. I think these days we have Parquet and Orc-file, but they weren't around, or haven't been around for that long. And then when things are into Hive, that's basically the main entry point for the analysts. They use some proprietary tools maybe against that, like the ClickView or Tableau or something else that will connect to JDBC. But also people write R code against whatever comes out of Hive, and they do a lot of Hive queries. So the nice thing here is I can run any of these things at any point in time, and they won't interfere with each other. The only thing that how they influence each other is, of course, what data is there. Right? So if you do these things out of order, you don't really know what is actually in the Hive tables at any point, except for the things that you put there, but then how much of the total volume is that? So instead of trying to guard against that upfront, we said this will happen anyway. People are going to be late with their data feeds, and sometimes they miss days, and then the next day you get the day bore and today, and then there's all these external factors that somehow influence whatever you can potentially be ingesting. But if you hold it back because not everything is there, then you're going to hold the analyst people from doing their jobs for a full day, which is also not optimal for well, bottom line oriented places like online advertisers and who knows what. So it will happen anyway. So what we do is basically we say you should always ask what is the use case for this particular piece of data, and only then decide what the quality should actually be, and then you can verify that before you actually run that piece of analysis. And this is where you use metrics to show the people that do the analysis what is actually in there, instead of saying the data didn't make it today because it doesn't meet the quality needs, so you get nothing. Of course, then when the metrics do show that something is severely wrong, you have to be able to make sure you fix it somehow. And fixing in our setup basically means drop a partition in Hive, regenerate whatever should be going in there, and then refill it. This is repairing things afterwards, because the other option is make everything transactional and have it, fail altogether or succeed altogether. And this is what all of the ETL tools, like the graphical ones, try to do for you, but it's just a really hard thing to do. And it works nicely for smaller workloads, but if you're ingesting tens of gigabytes a day from slow connections from outside sources, you always just want to go as far as you can, and you can fix it later on. And of course, we have these kinds of metrics that allow people to see whether what is in there is of enough interest to them to do their work, basically. Sorry about that. So, of course, for metrics, you can use one of the many things that's there already. You know about graphite, and maybe you can push data to Ganglia or something. If you want to go that far and have a lot of stuff, you can do things like OpenTSDB, or maybe there's a lot of metric solutions there. The only thing is that most of these things are they are for time series. What we have is not exactly a time series, because in the end we're going to be pushing things into Hive, and at that point potentially we're going to say, okay, what went in there is not complete. I drop it all together and I'm going to reinsert into that partition, but now it's the full set, right? So for all the importers, like the downloading, you have a metric, I downloaded so many gigabytes today, that's okay. You don't have to do anything there because it was missing before, then it adds up, and then the metric in the end is complete. Same goes for the processing, but you can actually do the transformation maybe 2 or 3 or 4 times, depending on whether something went wrong, or whether indeed the upstream source delivered additional sets that you should still be getting. And then, of course, you drop a partition and you recreate it, or you refill it, basically. So your metrics also need to be able to forget about certain things. And none of these tools really do that, because, well, it's a time series. So what we did is basically create a really simple web service. And all the different processes that do some kind of importing, they can call this through an endpoint or through an API, of course, that you have for the Jython scripts, because you have a library there. And they call the web service and basically say what they did. And then when you decide to manually drop something and recreate it, or manually say, this import happened, but I'm doing it again right now, you can fix the metrics in hindsight, and then in the end provide the analyst with a total view of what is actually in there. And that means that this is the stuff that is actually in there, and on these days, the upstream provider just lost it. Because, well, that happens as well sometimes. You have to be robust about that. Yeah. All right. This is the first time I ever did this talk, so I didn't have a clear feel for the timing of this. But it turns out, I think that we have 15 minutes for questions. So, thanks.